Hi everyone, I'm Richard Terry. I'm a Django developer at Lincoln Loop, and a big thank you to them for giving me time to come here and to work on nanodjango. Today I'm going to be talking about using Django from a single file, why Django doesn't let you do that out of the box, some of the dirty Python tricks we need to use to make it work, how I've wrapped those up in a convenient tool called nanodjango, and why you as a Python developer will find this approach useful if you need to work anywhere near the web. But first, let's talk about Flask. So one of the reasons people like Flask is because it's super easy to get started with. You open up a text editor, you write a function, and it just works. The same goes for FastAPI. The learning curve starts off gently, and you get to see things appear in your browser almost immediately. It's exciting. But if you try to do the same thing with Django, you have a few more steps, and you end up with this directory structure, which can be a bit off-putting, to say the least, even for seasoned Django developers. But this is actually one of Django's key strengths. It guides you into structuring your project well. You're encouraged to separate your code into logical apps. Your database models go into models.py, your views go into views.py, your URLs, admin, tests, management commands, everything has its place. And although it can feel like overkill at the beginning, it really is going to help you as your project grows. And Django can do this because it follows a batteries included philosophy. All the key ingredients for building a web app are baked in. The database, the forms, the admin, it's all right there, and it all just works all the time, every time you upgrade. As an aside, it's worth probably addressing the view that Django is heavier and slower than FastAPI. In the ways that matter, it's not. You can run multiple Django projects on a $4 DigitalOcean droplet, and it scales to power huge, high-profile websites serving hundreds of millions of requests a month with surprisingly few resources. So if you're going to hit a performance issue with Django, the chances are you're going to have that performance issue with Flask or FastAPI too. But to get back to the point, when you're just getting started, the project structure is overkill. If you just want to try out Django, it's off-putting. And if you know Django already and just want to pull together a quick prototype, there's a big mental barrier to getting started. So I thought to myself, why can't we have the best of both worlds? The convenience of the immediate results that you get with a single file with Flask and FastAPI, but with the power of Django's batteries, so you can achieve more with less code. Why can't we have Django in a single file? Now, over the years, a lot of people have done Django in a single file. It's usually a subset of Django because it turns out that Django really wants you to keep its project structure. Things don't really work if you move them around, so most people sensibly stop at implementing views. But that means you lose Django's batteries. Now, I have a bit of a track record for building projects that don't do things the way you're supposed to. Most of them start out with me saying, Python's great, you can get it to do anything if you put your mind to it. I don't learn from my mistakes, so I started nanodjango. So let's talk about nanodjango. To get started, you can pip install it, and the first thing we're going to do is re-implement Flask's hello world. So first we import and instantiate Django, and then define a function which returns our content. We register it as a view with the app.root decorator, and then we've got Flask's hello world, nice and simple. You can run Django's development server using nanodjango run, or you can serve it configured ready for production use using Unicorn. So that's Flask. What about FastAPI? Well, nanodjango has built-in API support using Django Ninja, so you can register an API view with app.api.get or .post, and we've got FastAPI's hello world. Behind the scenes, as I say, this is using Django Ninja, which is a fantastic API library that gives you everything FastAPI has, including nice Swagger, API docs, and schemas using Pydantic. And like FastAPI, we can also run asynchronously. So we just add async to the view definition, and nanodjango run and surf will use Unicorn instead. So now we're at the same level as Flask and FastAPI, but the whole point of this project is that Django has batteries, and we want to use them. So let's create a model. So here we have a simple model that logs the time that instances are created. And we can use it in our views directly. We can read, write, everything you can do with a model in a full normal project, you can do in our single file here. So when we run it, it's going to create a set of migrations for our models. It creates a database and applies them. It creates us a super user if we don't have one already. And then it runs run server or PYCON. And now we've got fully working models. There are more batteries. So we can add the admin site. We add a decorator to the model, app.admin. And you can also pass in extra arguments to customize the model admin. So now when you run the script, you'll have a full admin site. Now, if you want templates, you could load them from a templates directory, but you can also embed them at the bottom of the file. And that means they're out of the way of your logic, but they're still all in one file, which makes sharing your script a lot easier. So that all looks pretty simple. You've got a bit of a learning curve still, but it is a curve instead of the mountain. So that's great. But behind the scenes, I've been committing minor crimes against Python. So I'm going to skip over a lot of the details here, because we all need to go home at some point, but we'll look at the key tricks. So the first thing we have to do is persuade Django to start up without its precious project structure. It expects to have a project directory with a settings.py and a urls.py. The settings give us the settings and the URLs give us our top level URLs. And we're going to need to give Django some of this structure. So why not use nanodjango itself as the project directory? And first, we need to tell it to look in the nanodjango project for our settings. So when we initialize our Django class, we'll point at Django's settings module, and we'll point that at our nanodjango/settings. Then we'll call Django setup to tell Django it can get itself set up. Now the settings.py is going to have our default project settings, and that will point at our root URLs in nanodjango's urls.py. And that's going to be an empty list of URLs at this point, but that's basically enough for us to get started. Now, we're also going to need a convenient way for people to override our default settings. So let's take settings as keyword arguments to the dunder_init method. We can then set them directly on the settings module before we call Django setup. And now we can pass in settings when we create the Django object. So that handles initializing Django, but how do the view and the URL work? Well, for now, the view is just a function which returns a string. It could return quite a few different things, but how does this line work to set the root? Well, if you've not seen the syntax before, you probably have, but this is a decorator. A decorator is just a function. Here, app.root is a method on our Django object. We don't call this function directly. The @ sign means it automatically gets called when it decorates the function. So in this case, the function's our view, and root is going to get past the function that it's decorated, our view, and it'll then return it again. And Python will use the returned value instead of the original function. And that means we can create a new function inside that. And this is just going to call the original function with the same request. But then it's going to add a message to the end of the response. Root is then going to return this new function, and then when anybody calls hello world, they'll actually be calling our do something function, and they'll get back the changed message, hello world, lol. Now, adding something to our response isn't really what we want to do here. We want to register it at a URL. To specify the URL, we'll actually call the root and pass in a path. So we can ignore the app for a second. App.root will be called first, before it's treated as a decorator. So we could actually rewrite it like this. Whatever root returns is going to be the decorator now. So our root function now needs to return the decorator, a function which takes our view function as an argument and returns it like it did before. But here we're going to have all of the variables we need in the same place, the path, the view function, and self, our app. So we can add the view and the path to our URL pattern. This is very simplified, but you get the idea. And now we need to run it. As you saw earlier, the nanodjango run command does this bit for you with some extra bits like migrations, but I'll show you this so you can see how it works. So let's run it from our code at the bottom of our script. If this script is being run directly, if name is main, then let's call app.run. And if you've seen PEP723 defining Python's inline script metadata, we can actually put our dependencies in a special comment at the top. And then you can run it directly with UV without having to install anything else first. As for the run function itself, it's really rather straightforward. All the heavy lifting is going to be handled by Django itself using its standard execution flow. So we've re-implemented Flask using Django. But what about the models? So this is where it starts to get fun. Models need your app to be registered in Django's internal app registry. To do that, you normally put your app in the Django settings installed apps. But if we try to do that here, it's not going to work. because we're trying to add the current module, but it hasn't finished importing yet, so it's not available. That means the app registry will think it's not imported, so it will try to import it, and the same thing will happen again. We'll end up in an infinite import loop. So what can we do? Well, I spent a while trying various silly Python tricks to subvert Django's expectations, but then I thought, what if we can just trick the apps registry into not importing the model? It just had to think the model was already there. Now, the first problem is that Django expects to be doing all of this itself. It expects to be the one loading the apps during its setup, but we're running setup ourselves. So before we do that, we need to make Django think it's already loaded our app. Now, the first step is to tell Django where to find our app. It's going to need this for a lot of stuff it does later. To do this, we need an app config with a hardwired path to our script, so it doesn't try to find it itself. And then we need to make it think it found our app name and where our app module is in memory. We then manually add that to the app registry before we call Django's setup. And that way, the registry will think it has already loaded our app, so it doesn't try it again. So that's the app registered using the name of the file as the name of the app. And now whenever a model is defined in our app, it should automatically get registered against that name. What could possibly go wrong? Well, if we try to run it now, we run into another problem. As I said, models get registered automatically as they're defined. They're a bit magical. They're registered by Django's model meta class when they're defined, and that meta class has expectations about how our project is structured. Expectations we can't meet because we're breaking that structure. So some of you may be asking, what's a meta class? A brief diversion. A meta class is basically an invisible decorator for a class. It describes how your class is made. And if you define a base class with a custom meta class, it'll be made using the meta class's rules. And then every subclass it that inherits from that is going to have the same meta class, and it's going to have the same rules for how it's made. Now, whereas a normal class's init method will let you control what happens when your class is instantiated, the init method on a meta class will let you control what happens when your class is defined. And that means you can validate or modify your class. Or in the case of Django, you can register the class, the model definition, with the central apps registry. It's beautiful and slick until you need to change it. So as I was saying, the model meta class really wants us to define an app. It looks for the app name in the dunder module attribute of the model, and then it looks up the app in the apps registry so that it can register the model against it. But remember, our script is running directly, and the module name is dunder main. And the registry can't find dunder main because we just fixed that. It's our file name now. So we're going to get a fatal error that main isn't in installed apps. So to solve this, we need to change the way that Django's model base meta class works. Now, as a foolish man once said, Python's great, you can get it to do anything if you put your mind to it. So we don't need to persuade the core Django project to accept a patch for our weird little experiment. We can just monkey patch Django's meta class. Now, in case you're wondering what monkey patching is, a brief diversion. Monkey patching is the practice of changing other people's code at runtime. Python makes this possible because everything's an object, including functions. So we can put a reference to a function in a variable, and we can overwrite the original function just as easily. What could possibly go wrong? Well, quite a lot, obviously. This is why you normally only do monkey patching during tests. You mock out an API call or stub out a file system call, and if something does go wrong, it's just your test that fails. So here we're going to monkey patch os.path that exists to make it think that a special test path exists when it doesn't. You might do this in your tests. First, we create a reference to the old exists method. We define a new function which catches paths starting with test, and then we return true to say they exist. And then we pass the other paths back to the old behavior to see if they really do exist. And then at the end, we overwrite the old exists method with our new one. Now, obviously, if your code does something unexpected, you can break a lot of things. So we have to be careful. With great power comes great responsibility. So in that spirit, let's rewrite a core bit of Django's logic on the fly. Here we've got a bit of the model-based metaclass, which raises the error. Now, I've simplified it to fit on the slide, but we're failing because app config is none. And that's because dunder main wasn't found in the app registry, as we already said. But there happens to be this wonderful check right above it for an explicit app label. And that's going to be our hook to fix this. We just have to make sure every nanodjango model has an app label. Now, Django lets you specify the app label in the meta class. We could just ask everyone to put this in their models, but that's a bit messy, and where's the fun? So instead, we'll just replace the new meta class method on Django's base model meta class. So first, we check we're looking at a nanodjango model. We don't want to affect anything else. And we know which ones they are because the module name is main. So we can fix the module name. We just change the module to use our app name, the one that's already in our registry. And then we can add a meta class to the model with our app label. And then we can just call the old method and swap it over on the model base. So we're done. That's it. Django working in a single file. Just a couple of minor little things I have to sort out, but they're all fixed in nanodjango, so let's leave it at that. But there is one more thing worth talking about. If you recall at the beginning, I said that Django had two core strengths, that its batteries are included, and the way its project structure helps you grow. Now, our Django in a single file has the batteries, but we've lost the project structure. And that means this isn't going to scale. Your project is going to grow, and at some point, you're going to hit a wall. With everything in one file, it's no longer going to be an easy project to work in when it gets big. But that's okay, because when you get to that point, when one file feels too small, you don't need nanodjango anymore. You need full Django. So how do you get there? Well, nanodjango has a convert command, which will go away, automatically refactor your single file into a fully structured Django project that doesn't use nanodjango at all, with your models, views, admin, API, everything automatically in the right places. It does this by looking at your code. It parses the abstract syntax tree. It pulls out the bits it recognizes, the models, the views, the admin, the URLs. It puts them in the right files. And then it looks at the things they reference, so it can figure out where to put any extra code and what things it needs to import where. Now, because Python's great and you can persuade it to do anything, there are going to be some edge cases it can't handle. When it does end up with something it doesn't understand, it'll put it in a special unused.py file for you to tweak. If you have a library, by the way, where you want your code to end up in a special place, nanodjango has a plugin system, so you can write your own converter logic for anyone using your library with nanodjango. And this plugin system has turned into a surprisingly useful feature because it can really help integrate other packages and make the whole nanodjango experience a lot easier. For now, we've got 5 packages with integrations. We've already talked about how support for Django Ninja is baked in, but nanodjango will also automatically detect when Django Browser Reload is installed. And it'll set that up so that you get your pages automatically reloading when you change your template files. And it also integrates with a couple of packages I've written to support building nanodjango projects. The first one's called Django Style. This gives you very simple but tasteful base templates. We've got a pure CSS version, a bootstrap version, a Tailwind version, and each of those also has an app layout where the body has a fixed height, which is great for single-page apps. And these all support menus, forms, mobile layout. The idea is to make it easier for you to build really quick prototypes that look good without needing any boilerplate. This is a standard Django app, so it'll work with any Django project, but it works particularly well with nanodjango because with the plugin system, it can automatically detect when Django style is installed, so you can just straight up extend the base template without needing to write anything else. I've also released another package called Django Nano Pages. This takes a directory of markdown files and turns them into views with URLs matching your directory structure. There are some more features I don't have time to talk about, but it's fantastic for quickly building areas of static content on your site. Again, this is a standard Django app, so it can be installed in a full project with a couple of lines. But again, it works really well with nanodjango. It'll detect when it's installed, add an app.pages helper function to let you register the path at a URL. And nanodjango and nanopages also both integrate with Django Distill, so you can use all of this as a really minimal static site builder with the power of Django behind it, which means you can bring in models and the admin site to add content to a local database and then build pages from that right next to your markdown content. So this all sounds fun, but what can we actually do with it in practice? Well, I wasn't expecting it when it started, but it turns out that this is a really powerful tool. It's fantastic for learning. You get the Flask and FastAPI beginner's experience. It makes it really easy to pick up Django and get started. It's great for experimenting. Not sure how something works? knock up a quick nanodjango script to try it out. Prototyping. If you've got a complicated project in mind, you can build the hard bit first without all the boilerplate to get an immediate proof of concept. It's also good for sharing working examples with other people over email, Slack, or forums, and even for building simple sites, static sites or small content sites with a simple app or two. And it's even useful if you're on a big project and need to do something a little bit different. So in my day job, I work on a large Django project that's been actively developed for well over a decade. We want to introduce some async views for performing real-time LLM queries, but without introducing async to the core platform, at least not at the moment. nanodjango is perfect for this because we can build a compact set of async APIs and views for this one task with models and an admin to control things. And then we can deploy it as a self-contained single-file service, a microservice. And because it's still Django, maybe we can integrate it back into the main code base at some point in the future, if we ever want to, and if we ever go full async. Another real-world example is where I built a website for a Discord group that I manage. We've got a daily prompt to get the conversation going each morning, so I built a simple website using nanodjango, where members can log in via, using Discord, they can submit their prompt ideas via a form, and I can curate them in the admin site. And I then have a sidecar, a separate Python script running a Discord bot. Because a nanodjango script doesn't automatically run anything when it's read by Python, my bot can import it and access the models and the ORM completely independently of any web process. So in this code, once a day it pulls out today's prompt from the database and posts it to the main channel. Another example is where my colleague Jan implemented the Pydantic AI chat example in nanodjango. Their example was using FastAPI, but his nanodjango version is about 30% shorter, partly thanks to Django's ORM, which removed a lot of the raw SQL code and management and made it easier to follow and maintain. He's also been using nanodjango to build a prototype for using Temporal with Django. Temporal is a durable workflow platform, essentially resilient queues and tasks. It looks pretty neat, so we've been looking at how we can integrate it with our Django projects. And nanodjango has been a great way to experiment with the Django side of things. And because both the nanodjango script and the Temporal worker were both async, we were able to run them together in the same async loop in a single process. So with all the things I've been writing and seeing other people write, I thought it'd be really good to have somewhere to share them. So nanodjango now has a website at nanodjango.dev. This has more detailed introduction as well as documentation, and soon there'll be how-tos and links to other people's things. But it also has a fun and potentially useful new feature. The nanodjango playground. So this runs full Django in the browser with nothing to install. You put your code in the editor pane on the left, you click run, and through the magic of Pyodide and far too much JavaScript, your nanodjango app will run and be accessible in the pane on the right. It supports links, get and post requests, API calls, models, migrations, everything as if you were running it from the shell, but it's entirely inside the browser with nothing to install. So I'm really excited about this. I think it's potentially great for beginners. It makes it really easy to try out Django. And soon you'll be able to embed playgrounds in your own sites, which will be handy for tutorials. And it's great for more experienced users because you can save your scripts and share them with other people, and even have live demos of your project running in the browser in a safe environment. So I've got a lot more ideas. Keep an eye on the blog or my Mastodon account to find out when I release things. But I really look forward to seeing what people can build with it. So hopefully you've got an idea of why Django in a single file might be useful, and you can see how nanodjango makes it easy to achieve. If you've been considering starting a project with Flask or FastAPI, do take a look at Django and nanodjango and see if they might be a better fit. And even if you've been using Django for years, please do give nanodjango a try and let me know what you think. If you'd like to come to chat with me about anything I've talked about, or have any ideas, I'll be around for the rest of the day and most of tomorrow morning in the sprints. Thank you.
Thank you, Richard.